Sanger Institute was founded approximately 20 years ago to form the British contribution to the Human Genome Project. The Wellcome Trust is one of the largest medical charities in the world, with a focus on healthcare issues facing the population worldwide, including cancer, diabetes, various diseases such as malaria. And my job as the head of scientific computing is to provide the IT infrastructure which enables the scientists to do that research. The idea common to all of our research programs is to identify the variation in the human genome that gives rise to a particular condition. Traditionally, you have an idea about what causes a particular disease, and you do experiments to see whether your hypothesis was correct. Modern DNA sequencing has enabled a different approach, which is to say, I don't actually know what the causing variant is, so I'm just going to look at everything and see what comes out. That's the big data approach that's now become feasible as a result of advances in DNA sequencing and the IT to support it. In order to detect a variant that causes disease in maybe only 1 in 1,000 people, you have to sequence tens of thousands of individuals in order to reliably find it. The Sanger Institute's sequencing facility now produces more data every hour than we did in our entire first 10 years of operation. DDN have helped us a great deal, particularly in our high-performance computing storage, where these increasingly large experiments have needed ever higher amounts of performance and data capacity. DDN provide us with 10 petabytes, most of which is used as high-performance parallel storage for feeding our 17,000 core high-performance computing clusters. The improvements in the I/O capability of DDN Lustre appliances has required us to upgrade our networking. Initially, we started out with normal network-attached storage on gigabit Ethernet, which can get you about 100 megabytes a second. And as we moved through various generations of DDN's Lustre equipment, we've gone through 3 gigabytes a second, 6 gigabytes a second, and we now run 40 gigabit Ethernet connections in order to keep up with the data that these storage systems can deliver. The large quantity of data that we produce has to be managed, and the system that we use for that is called iRODS. It's a key strategic technology, and DDN provides a large proportion of the storage that we actually put underneath it. These machines are running at the absolute limit of what they can do. Support is critical in this space. We've had very good engagement with the technical people at DDN. They're very smart guys, and they have always delivered on the promises that they've given. DDN's solution has helped us to deliver the throughput and scalability that we need to support the tens of thousands of DNA sequences that we generate. To deliver the Sanger Institute's world-leading research, we have to have world-leading IT to go with it. And DDN has been a significant contributor to delivering that.